When you succeed, we succeed.
Hi, today we're gonna continue discovering Calibry Nest software. In this particular tutorial, we're gonna pay more attention to the settings menu and which settings you should use for finalizing your objects in Calibry Nest software. To finalize a 3D model, we need to choose which scanner was used for scanning this object. This will help us to figure out which setting should be used here. As you can see, there are several presets already in the software by default. In this drop-down menu, all 3D scanners manufactured by Thor 3D company are listed. The settings will change according to the presets you choose. They depend on a model of a scanner you use to scan an object, and on a type of an object you scanned. The presets come handy when you want to make the process of finalizing objects simple and fast, especially if you scan only several kinds of objects. Let's say that the majority of the scans that you do are humans or industrial parts or pipes. You can make your workflow more efficient by updating the existing presets or by adding new ones, which will allow you to use them in the future if you scan similar objects. If you change the default presets, they will keep at the default value. But if you want to recover to the standard settings that were set for example, Calibry Industrial or Calibry Human, you can always just click on Default right near the preset and it will change back to the default value. We suggest these values to our partners and clients because over the time we figure that these values may not be the best for some particular objects, but on average they give you a nice result. Now let's talk about the most important settings that are necessary for creating a polygonal model. The values on the left affect the polygonal model, while the models on the right create an additional information and affect texturing, so most likely you will be interacting with the values on the left the most. The very first value here is resolution. You need to change it depending on what model of a scanner you used and also what type of an object you scanned. For instance, the highest resolution for Calibry is 0.6 millimeters. And so you can set it to 0.6 millimeters if you need the highest possible resolution if you use the Calibry scanner. If you mainly scan humans, the range that we recommend to use is between 0.6 millimeters to 3.5 millimeters. But keep in mind that the lower the resolution, by lower I mean the value is closer to 3 millimeters, the less facial features the model will get, and you might see less details on the polygonal model. If we get a closer look to the presented 3D model, we can see what exactly is resolution. By zooming in, we can see a polygonal grid of the object. Here we can see thousands of polygons that combine into one mesh. And if you look at polygons, they are basically triangles. And each triangle has 3 sides, and resolution is the length of each side. So basically, if you set your resolution level to 0.6 millimeters, each side of any triangle will be 0.6 millimeters. Next setting we're gonna talk about is the algorithm of filling up holes. Here we can fill up holes either by radius, all the holes from the smallest to the biggest one, and none at all. You should go for filling all the holes only if you're sure that you scanned a whole object, or if you aligned several parts of one object and you're creating a final 3D polygonal model. In that case, all the holes will be filled with the help of the algorithm, and the model will become watertight and suitable for printing on a 3D printer. Another option here is to fill up holes by radius. As it's shown here, you can set radius to 5 millimeters as in here, and all holes that are smaller than 5 millimeters will be filled up. But the holes that are bigger than 5 millimeters will stay on the object, and if you need to fill them, you can do it later with our special tool. And the third option of not filling any hole is used when one needs to see the edges really clearly without any extra polygons. This mode is also called measurement mode, meaning that some objects might have edges with really microscopic holes there, and they don't really need to be filled. Otherwise, if you choose to fill those holes, some extra polygons might be created there. To avoid that, just fill the setting not to fill any holes. But it's really helpful not only in this situation, but also in situations where your objects have some small holes that you want to keep. For example, you're scanning a metal part with a lot of holes in it, and they are really tiny, and if you choose to fill all holes or fill holes bigger than some radius, those holes should be bigger than that setting, otherwise they will be filled too. The sharpness setting will affect how your final polygonal model will look like. If you dial that setting to the very left, it will smooth out your object. Let's say you scan a human, and if you move the setting to the left, you won't see much facial features, you won't see much of nails, and overall your model will be really smooth, not sharp. But if you dial the sharpness setting to the very right, you'll see more features of face, or if you scan metal parts, you'll see sharper edges. All our scanners are optical. They project a light grid onto objects. And if you dial the sharpness setting to the left, the light grid in the areas where data is lacking will be less distinct. But overall, you can experiment with this setting. On average, we keep that setting somewhere in the middle. A lot of people never change this setting because the effect it has on the model isn't really that significant. Next setting is preliminary cleaning. It cleans out the noise that have been captured with the actual data. Preliminary cleaning should be done only once during the first registration. Preliminary cleaning is included into registration process. It will erase all the noise that's floating around your object. It'll help to align all the frames together by removing the data that isn't presented in several frames but only in some single frames. Next setting is removing markers. As you may already know, our scanners have marker tracking mode. When you put markers on the object and scan it, this function allows you to delete them. If scanner that you use is Calibry, the optimal value here is 9 millimeters. But this value is applied only to those markers that are supplied with a scanner. Those markers have a perfect round shape. But if you print out markers by yourself on adhesive paper, you can cut them out not in a perfect circular shape. In fact, you can easily cut them out in a square shape, but the edges of that little paper will be on the polygonal model. And in order to get rid of them, the radius of that marker should be increased a little bit. So 9 millimeters is perfect for a round marker. But if the paper your marker is on is a little bit bigger than that, just tinker a little bit with that value. It can go up to 10 or even 11 millimeters, and that's how you can get rid of all the unnecessary data that is connected to a marker. Next setting is called filtering by size. It affects not the frames, not the raw data, but the final polygonal model. And if there are any small particles that you want to erase, or any small parts that you don't really need, you can erase them with this algorithm. You can set it to filter by size, and as you can see here, we have a setting of 2000 polygons, meaning that any objects that contains less than 2000 polygons will be deleted. Alternative here is to leave only the biggest part. This way, anything that isn't connected to the main part of an object, to its bulk, will be deleted. Next group of settings is related to texturing. In this drop-down menu, you can choose what dimensions of the texture map you would like to have, the dimensions of the final PNG file. When you create a textured OBJ file, it also creates two additional files. One is MTL, the other is PNG. Next setting is floor detection and floor creation. These two functions are primarily used for creating 3D scans of people. Floor detection detects any turntable that is underneath a person. This way you can delete any floor or basement or turntable that a person was scanned on. It greatly helps to reduce time on creating scans of people, especially for further 3D printing. If you scan people on turntables, you can easily get rid of the turntable and instead create a nice looking basement for further printing on 3D printers. Here you can set the number of size of that nice looking basement. It could be a square-like or octagon-like, basically any shape that suits your taste. As well as the shape of the basement, you can choose its height, its radius, so whichever size, whichever shape, you can create it with the help of these three values. If you don't need any basement, just tick off all these settings and no basement will be created and there will be nothing underneath of your scan. Next is remeshing. Remeshing allows us to create a nice-shaped triangles, nice-shaped polygons. Let's see how it looks like. Let's zoom in on our 3D model, also turn on the wireframe view. Right now our model consists of a plethora of randomly shaped polygons. If we set the value of remeshing to 1.8 millimeters and choose which object we would like to remesh, we will see what will happen to it after remeshing. Remeshing is normally used to make the wireframe look more neat and orderly, because later on it will be much easier to work with a neat wireframe rather than the chaotic wireframe with a lot of weirdly shaped polygons. Here you can see what happened to the wireframe after remeshing has been applied to it. All the polygons are nicely shaped and are in order. If we switch back to the shaded model, the model itself now looks better and smoother. And the last setting is simplifying. Here you can set either an absolute value or a portion of polygons that your model already have in percents. If you have a specific amount of polygons that you like to have in your polygonal model, you can set the value to that specific number. We can split polygonal models into two groups. One group that has a really high number of polygons, and the other group that contains a lesser amount of polygons. 3D models with a higher amount of polygons are good for designers because it gives them more freedom of editing those 3D models. But for some engineering purposes, it's much better to have a lesser number of polygons in a 3D model, since some CAD software do not open 3D models that contain too many polygons. So depending on the areas of use, you can set these values to your preferable number. If you're planning to put texture on your 3D model, we also recommend simplifying this model before texturing it, because it takes much less time than if you weren't simplified the object. The faster you want to put texture on the object, the higher the level of simplification you should choose. Also, don't forget that simplification loses high resolution. These were all the essential settings that you need for creating a 3D model out of a raw data captured by our scanner. In our next lessons, we're gonna show you more examples of how to use these settings and what settings you should choose depending on what result you are seeking. Thank you for watching. Goodbye.